So, hi, welcome everyone. Welcome to multi-tenant software architecture, or as I like to call it, keeping the noisy neighbors happy. The first question which I'm trying to answer is, why are you all here? Why are you sitting here listening to me? And what I want you to take out of it. So, let me tell you a little story. I'm a software consultant for the past few years. I've worked for a lot of companies doing quite a lot of things. But the common thing about most of these companies is that they built a product. Now, this product could be something very simple. It could be a very complex, gold-plated, expensive system. It can be some legacy system which would have been burnt a long time ago, but they're still maintaining it and selling it because it brings in the money. Okay, so it doesn't really matter what the system does. It's a product, and the company sold a product. Now, the customers, when they buy this product, do you know what else do they have to do except for buying your license? Usually, they need to buy the hardware to run your software. They need to configure it. They need to install it. They need to maintain it. They need to upgrade it. They need to do a whole bunch of IT-related stuff just to run your software. And guess what? They don't like to do it. They don't like doing that. They just want to go click a button, get your software up and running. And that's where we enter the world of the cloud. Customers today come to vendors and they say, well, I want not a product, but I want a service. I want to go to a website, click a couple of buttons, tweak a couple of knobs, the number of users, the throughput I need, or whatever else that's required. Enter my credit card number because I need to pay for it. Click go, and then something automatically happens behind the scenes, and I get my software running. No IT, no hardware, no installation, no monitoring, no anything. Now, since that's what the customers want, a lot of vendors want to do that. So the vendors say, hey, let's take our system, whatever it is, doesn't really matter. Let's throw it up into the cloud. Let's get it running, sell it as a service, and off we go. We'll make bundles of money. But you know what happens next? Something like this. Okay, reality hits them. They come and say, something like customers come and say, okay, how do I know you're secure? How do I know that you're properly securing my stuff? When new customers come in, how do they provision new resources? The company, the vendor. How does the vendor monitor it now? Because now they're not in the business of selling products. Now they're in the business of maintaining a running system, a live system, which probably needs to run 24/7 and maybe serve customers potentially around the globe. That brings in an entire new operation to this vendor. And that's where I come in, or the software architect, to try and show them how much they should do and what they should work on in order to get their software running up in the cloud. So what are we going to talk about today? First off, we're going to start with a couple of definitions. We're going to define what is a multi-tenant software system. We'll define what is a tenant. We're going to talk about who is the tenant. The bulk of the talk will be around architectural issues involved in creating multi-tenant software as a service systems. In the last couple of minutes, we're going to discuss a couple of DevOps issues which you should probably take into account as well. But before I start, I have a question for you. How many of you are software architects or define yourself as software architects? Raise your hand. Okay, let's say half. I have a question for you. What is the best answer a software architect can give to any question? Yeah? It depends. Right. Have you seen me before? No, I probably haven't. It depends. Okay? What technology stack should I use? It depends. Should I write a web or mobile client? It depends. Which cloud vendor should I use? It depends. You get a picture. So I have a short disclaimer to give you. In this session, I will not give you the answers, or I will not give you all the answers of how you should build your system and take it up to the cloud and not as a multi-tenant software as a service system. But what I will attempt to give you is give you the questions you should ask and some tips, some pointers. We have a couple of demos of how you can solve these questions usually. But again, there's no one size fits all for these kind of scenarios because, again, it depends. Remember that. So I hope you get the most out of this session. My name is Eran. I'm the cloud division leader of a company called CodeValue. We're a software consultancy in Israel. I'm a software architect, a Microsoft Azure MVP, and also founder of one of the biggest meetups for Azure in Israel. One of our products is Ozcode. We have a booth outside. If any of you are C# developers, I do encourage you to go out there and check out the booth to make your life much more better. So let's get started. What is multi-tenancy? Okay, I said a lot of time, multi-tenant software as a service system. But what is multi-tenancy? Okay, the term software multi-tenancy, okay, and this is from Wikipedia. Wikipedia sometimes has pretty good definitions, and we're going to go with that. The term software multi-tenancy refers to a software architecture in which a single instance of software runs on a server and serves multiple tenants. Okay, the key thing here is that we have a single instance of software, one system which gives service to a lot of tenants. We'll get back to the single instance later on. But what is a tenant? A tenant is a group of users who share a common access with specific privileges to the software instance. Let me give you an example. It's my company CodeValue. We use Office 365. Office 365 is Microsoft's service with Exchange Online, SharePoint Online, Microsoft Teams, all kind of productivity tools for organizations and enterprises. So if we look at that as an example, why is it bothering me right now? Sorry for that. If we look at Office 365 as an example, all the users of CodeValue, my company, are a tenant. Why? Because we share access to the same files on SharePoint Online. We share access to the same teams on Microsoft Teams, to the same channels, to the same data. Not all of us necessarily have access to exactly the same information, but we share the permissions on the same items. If we have now an employee from another organization who is using Office 365, he won't see this data, he won't see these files, he won't see these channels. Why? Because it's from another tenant. Okay, so a tenant is a group of users who are related to each other in some way, and they usually have access to the same resources, or they have permissions to access to the same resources. With a multi-tenant architecture, a software application is designed to provide every tenant a dedicated share of the instance, including its data, configuration, user management, tenant individual functionality, and non-functional properties. And it could be a lot of things, but all the tenants users have access to the same things, as I said. Now, the last part is interesting. Multi-tenancy contrasts with multi-instance architectures where separate software instances operate on behalf of different tenants. Let's go back to the system I told you at the beginning. Let's say we have that software system running on premise, we take it to the cloud. We want to take it to the cloud. A valid solution would be, is to say, let's create some sort of portal for customers to log in, and let's say a customer comes in and buys our product. Then we can say, okay, when a customer buys our product, we'll spin up an instance of the system. When another customer comes in, we'll spin up another instance of the system dedicated for that customer, and so on. Is it better or worse? What do you think? What's the answer? It depends, right? It really depends on your requirements, and we'll talk about it very soon. But the key thing here is if everything is separated, then it's not really a multi-tenant system. It might be a software as a service system, but I like to call it multiple single instance software as a service, because we have a lot of single tenant instances. And that's fine, that's a valid solution. I've done these before, but you should bear this in mind when we talk in our talk today. So we describe what are multi-tenant systems, but we describe what is the tenant, but who is the tenant? And let's say this is our system, these are our customers, and let's say that the building that's now marked on the slide is an organization. Is an organization necessarily our tenant? What's the answer? You should remember it by now. It depends, right? Sometimes it's an organization. Sometimes it's a division inside the organization who is the tenant. And sometimes it's a department inside the division who is the tenant. But how do we decide? Let me tell you a story. A couple of years ago, I worked for a big multinational corporation. And they had this on-premise software product which they sold to customers. And it was very successful. They didn't want to replace it because what it did, it was managing a couple of machines on a manufacturing floor, so it can't be done from the cloud for many reasons. But they wanted to add some additional value-added services from the cloud, which are subscription-based, which will interact with the server, with the software, and they'll give additional services. So initially I thought, well, every organization who buys this product is a tenant. But then the product people came in and they told me that actually when they're dealing with large multinational customers, then a lot of the times each division at that customer will buy the software separately. They will get a separate bill. They have a separate customer ID in the vendor's database. So they're not really connected to each other. So well, okay. So if we have small customers, then the organization is the tenant. If we have large customers, then each division or each entity which corresponds to a client ID in the vendor's database is a tenant. And that defines the scope of the users. But then they came in and told me, well, if we sell this service to multiple divisions at the same company, the managers will definitely want to see a report across all the divisions, because otherwise we're not giving them a lot of value. And wait, you can't do that because no one can have access to a lot of tenants at the same time or have a lot of data, so it's the same tenant. But then he came back to the first position. And we had a lot of discussions there. Eventually, we built a hierarchy there of tenants, so it was a more complicated case. But I just want to tell you that who is the tenant is a question that you should ask your product teams, whoever is defining the product. But let me give you another question. Let's say we have tenant A in blue and tenant B in red. Now let's say we have a user who is an employee of organization A and he's using our system. And he has his user account, he's using the system, everything's great. Then one bright sunny day decides to leave. What does he do? He's moving to organization B. Now what do you think? When an organization B is using the same system, the same software as a service system, should that user, that employee, get a new set of credentials and basically have a new user account? Or should his existing user account migrate with him and just give him permissions to the new tenant? What do you think? Which is better? It depends, right? Again, because this is not a technical question. This is not a marketing question. Again, a product question. What is the requirement? Both are valid cases. If, for example, the account is, let's say, in my case, I work with code value, so my account is Eran at codevalue.net, and it's an organizational account, then if I work for another company, it makes sense that I'll get another account. But if I'm using, let's say, a Google account or a Facebook account or something, it doesn't make sense for me to open a new Facebook account just because I moved to another organization, right? So it's more of a permission issue. So this is a requirement, and sometimes you have to support both, by the way. And we can complicate this. Let's say that this user is not a full-time employee. Let's say he's a consultant like me. And now he needs to work for both organizations at the same time. Does he have two separate users account? Or one user account with permission to both tenants at the same time? That's a good question. Again, question for the requirements. That's a question you should ask yourselves and whoever is defining the requirements for a product. Okay. So we talked about multi-tenant systems. We talked about who is the tenant. We talked about who does the user belong to. These are three basic questions that you should keep in mind and ask yourselves. Let's go talk a little bit about architecture. And now, as opposed to what he said here, you should really take the time and get the architecture right when you're migrating to the cloud. And we're going to discuss a couple of questions you should really ask yourselves. Now, as we go along, we'll have a couple of reference architectures, which we'll see how they evolve as I answer more and more questions. So let's say we're talking about a messaging system for an organization, something like Slack or Microsoft Teams or whatever, but it doesn't really matter the domain. And let's say it's implemented as a monolith. So usually we'll have like this in the middle, the backend API, maybe it's a ball of mud, maybe it's something more organized, but it's a big something with all the business logic. We have clients on top of it, and we have multiple data stores below, whether it's SQL for relational data, blob storage for maybe attachments, pictures, stuff like that, and Redis cache to make things work faster. So that's one possible implementation. Another implementation, maybe a microservice-oriented implementation, maybe on Docker, will look like this. We have a reverse proxy, maybe Nginx or something else. We have the clients on top. Clients coming in are authenticated using some sort of authentication service, which is right here. We have a user service for managing all the users, their properties, the relationships, who is a friend of who, and so on. And some sort of message service for storing the messages themselves, the attachments, and so on. So this is the possible implementation in microservice-oriented architecture for an on-premise system. And let's see how it evolves. So first of all, let's talk about the first question that you should ask yourself. Shared resources versus dedicated resources. The first type of resource is shared resources. In here, we have a space. It could be a compute space like a web application, or it could be a data space, a storage space like a database or a storage account or whatnot, where multiple tenants get the requests served at the same time in the same place. Those are shared resources. The other type of resource that we might have are dedicated resources, where each tenant gets their own dedicated space. So, for example, if it's a database, we might have a database per tenant. Or if it's a web application, we might have a web application instance per tenant. And then we need to figure out where to route the requests. So we have shared resources and we have dedicated resources. When you have your architecture, like I showed you before, you need to go over each and every resource and decide, is this a shared resource or a dedicated resource? If all resources are dedicated, then we said it's not a multi-tenant system anymore. It's a single tenant system. But assuming some are shared and some are dedicated, we need to figure out which is who and how do we manage it. So why should we favor each? Why do you think we should favor shared resources? Anyone? What's the major benefit of a shared resource? Cost. Right, exactly. The major benefit of a shared resource is cost. And why is that? Assuming, let's say we have multiple tenants, we have tens or hundreds, it doesn't matter. And if we give a dedicated resource for each and every one of them, we need to prepare for the maximum expected capacity of that tenant. We need to over-provision for each and every tenant for the expected maximum capacity. Obviously, we can scale each resource if we're using the cloud, but still, we need to provision enough capacity. If we're talking about a single instance which serves multiple tenants, let's say a web app or something like that, then assuming that not all tenants do the operations at the exact same time and reach the peak load at the exact same time, the load averages over time. So we don't need, let's say we have 100 tenants, we don't need 100 n times resources, we might need 70 n or 50 n. It really depends on how the load distributes. But it will be cheaper, and we get advantages for size. So this is the main reason why to use shared resources. We'll use dedicated resources for security and privacy. Obviously, let's say we have a database per tenant. If we connect the correct database for a request, and that's a big if, okay, we'll get to that. But let's say we connect to the correct database for a given request, and we know the correct tenant, then no matter how bad our query is, we can't get data from another tenant. And that's the biggest thing you should be scared of. Giving access to one tenant to another tenant's data. Okay, that's something you should be really afraid of. That can take you out of business, literally, if that happens to you. And let me tell you a story. A good friend of mine is using a multi-tenant service from a big corporation, which you all know, but I won't name them right now. And he was using it, and one day he got a bill, like usually does. But the bill had information for another customer. Now, you can assume that if that gets public, that's pretty bad, because you sent one tenant's information, maybe sensitive information, what they're using, what prices are they paying, and so on. You send it to the wrong person at another organization. Okay, so you need to be really careful. When you're working with a dedicated resource, you minimize the risk. Okay, so these are the reasons of why should we favor each. But how do we decide? How do we decide for each resource what we should use? Now, the first thing we can use is the requirements. Go to a product team and ask, what is our versioning or deployment strategy? And now, think about that if we have a shared resource anywhere, then that really makes it harder for us to version or deploy separately for tenants. So if all our resources are dedicated for a single tenant, okay, so it's not a multi-tenant system, I told you, but then you can deploy or give a version for each tenant separately. And then you can cater for various requests of various tenants. Obviously, this turns into a management nightmare because you have to support multiple versions at once. But sometimes, if you don't have a lot of customers, this is a good choice. Another option would be that if we have shared resources across a region or deployment, let's say a system is deployed in the United States, in Europe, and in Asia, for example. So if we have shared resources at the regional level, at the deployment level, that means we can deploy only a single region at once. We need to update all tenants in that deployment at the same time. We can't give separate versions to separate tenants. The same thing happens across the global scale. If we have a shared resource which is global, let's say we have a replicated database across all the globe, let's say using Cosmos DB or some sort of MongoDB replication or whatever it is, then you're pretty much tying yourself together across the globe and you need to update the entire system at once. Now that usually means that you need to have an operating system for 24/7. That raises the question, how do I update my application while it is still running? How do I update my database schema while it is still running? But that's another set of questions which is not specific for multi-tenant systems. But you can go to your product teams, you can ask, what is our deployment or versioning strategy? And that will give you a hint as to where can the shared resources and what scope can they be, shared or dedicated. Another thing you can look at is the state management of the resource. So for example, if we have a stateless resource, it could be, let's say, a web application, and we built it stateless because we were always taught that stateful services are bad. So let's say we built it stateless. Then if it doesn't have any state, it's a good candidate to be shared across multiple tenants because no state is kept between requests. We still have to be careful though. A lot of the times we have, like static variables or all kinds of thread contexts which move around and stay in all kinds of places. We really need to be aware of those and find those out to make sure we are really, really stateless. So again, there's no case that a thread which served one tenant will be used to serve another tenant and they'll have something on the thread context and you're pretty much done. So you have to be careful, but again, stateless services are usually a good candidate for being shared resources. On the other hand, if we have stateful resources, like a database or a stateful web app, that's a good candidate for being a dedicated resource for that tenant. And it's obvious because if we have state and we know the state is scoped to a single tenant, then if the request arrives at the correct instance, then we're good. Again, it doesn't always say that needs to be the case. Sometimes if I tell you, for example, for a database, and my recommendation for database almost always is to create a database per tenant because it gives you good security. A counter argument to that would be, it's too expensive. We now need to create hundreds of databases or thousands of databases. It's not only expensive, we need to manage it all. So these are all correct arguments, and I'll give you a tip on how you can do that in a couple of slides. But again, they're good candidates for becoming dedicated resources because personally, in my opinion, I believe that the security and the privacy concerns are more important here, but again, it depends, like I told you. On the other hand, if you have something like a cache, let's say Redis cache or any other in-memory cache, if I tell you to set up a Redis cache for each tenant, and let's say you have hundreds or thousands of tenants, that would definitely be way more expensive than you probably want to spend because it will cost your customers a lot more because Redis is in memory, and memory costs a lot of money. So in that case, I would usually go with keep the single Redis cache, just make it bigger, use the size. But you can use all kinds of tricks. For example, when you access a Redis cache, if you access it through some sort of infrastructure you control, you can always concatenate the tenant ID to the key which you're accessing. So if all of your code accesses the Redis cache through the same infrastructure, and we'll talk about the infrastructure later on, but if all the code accesses through the same infrastructure, and the infrastructure you know that it's tested and it always adds the tenant ID. If the tenant ID is not there, it will throw an exception, for example, then you can be pretty sure that the data in the Redis cache will be separated. So if you look at the monolith architecture you saw before, it can turn into something like this, where we can say that the backend API is stateless, for example, so it will be shared, and the SQL and blob storage are stateful, and we want to create one per tenant, so there'll be multiple of them. And in the Redis cache, we create some sort of logical regions for using appropriate keys. Or if we look at the the microservice architecture, it can look something like this. We can say that, for example, in this case, the user service is common because a user might belong to a lot of tenants, because that's the requirement. I told you, it depends on the requirement. But the message service, we can decide that it will be per tenant. And then we turn it into a routing issue. Because when a request comes in, and let's say the reverse proxy is aware of the tenant, like maybe it's in a header or in a signed token or something like that, then the reverse proxy can route the request to the appropriate instance of the message service, and then it becomes a simpler problem. Okay, so that's the idea of what you can do. Now, it doesn't have to be always one or the other. There are types of resources which can help you get the best of both worlds, both cost and security. So for example, if we have the Azure App Service, as you might know, in an app hosting plan, you only pay for the resources, but you can provision as many web applications as you want. Obviously, provisioning many web applications has its cost because you're using resources, but you only pay once for the pool of resources that you have. The same thing goes to storage accounts. You only pay for the storage. It doesn't really matter how many containers do you have or how many storage accounts do you have. There is a limit on the number of storage accounts, but it doesn't matter on the billing itself. So you can separate for containers, for storage accounts, depending on the number of tenants you have. And the one I want to demonstrate is the SQL Server. In Azure SQL, we have a mechanism. It's called Elastic Pools. How many of you have heard of it? Raise of hand. Okay, few. Okay, great. So Elastic Pools are a mechanism which was built specifically for ISVs, where you can buy a pool of resources. Instead of buying a database one by one and paying one by one, you can buy a pool of resources and you can deploy as many databases as you want. Obviously, there is a limit, but you can deploy multiple databases in that pool, and all these databases will share a pool, much like a logical server. Let's say you have a logical server, you can run multiple databases on top of it. So using this abstraction, we can pay once for the pool of resources, and assuming not all tenants have their operations at the same time, the load will be spread, but we'll get one database per tenant or one database per several tenants, we can decide. So let's see how it works. Okay, let's get out of PowerPoint. Now, all the code I'm showing you today, it's all on GitHub, on the public repository. I'll make sure to post it, the URL, when the slides are up. But if you want to, you can look on GitHub, Eran Stiller. It's called Noisy Neighbors. You'll find there all the code. So let's see what we have here. I have a script here, a small PowerShell script. This can be done for ARM templates, for the portal. It doesn't really matter. It creates a resource group. It creates a SQL server. We have here a new Azure RM SQL server. It creates the firewall rules to open up the ports in the firewall, the IP addresses. So far, it's pretty simple. And then we create something which is called Azure RM Elastic Pool, which is what I told you. So we can see I specify the tier. This defines all kinds of features that you can get. And the DTUs, database transaction units. This defines the scale of the pool. Okay, so we can start from 50. 50 is the lowest one. You can go higher as much as you need. There are limitations for each tier. Now, I can also specify database DTU min and database DTU max. I can guarantee that each database will get at least 10 DTUs in this case, so that no tenant will be starved because other tenants have a lot of operation. I can also define the maximum. Okay, so no one tenant will get a lot of resources while others, again, don't. So I already ran the script, and if I go to the portal, I open the Elastic Pool. It created a resource called an Elastic Pool. Okay, we can configure it. We can see that every database has 10 to 20 eDTUs. It has 50 elastic eDTUs, elastic DTU in total. This one already has 4 databases. I'll show you how they're created. But you can see here, and you can see the resource utilization. Right now, it's doing nothing because I didn't run anything on the pool. And once I have databases, which I'll show in a moment, we can see the utilization per database. So let's say I ran the script. I created the elastic pool, but how do I use it? Now, I can use the elastic pool just like any other SQL server. I can create a database with PowerShell, with T-SQL, with ADO.NET, with whatever you want, and it works. You just need to specify, there's a way to specify that the database should be as part of a specific pool. So that'll work. I'm not showing that. What I want to show you here is a small application, which is based on the Elastic SQL samples. As you can see, it uses some sort of library. The Microsoft Azure SQL Database Elastic Scale Shard Management. Some of you might have heard the term shard. Shard usually refers to when you have a database and you split it up due to scale. Each part of the database is usually called a shard. Now, a shard can be on a regional basis. It can be on a date basis, on a time basis. In our case, it will be on a tenant ID basis. We'll shard the database according to tenant IDs because that's what I want to do. So this utility, what it gives us, the SDK, it gives us a class. It's called Shard Map Manager, which allows us to create shards and create the mappings for the shards. So I'm not going to go into the details of how this code is built. You can download it later, and it's pretty much straightforward. But we create this Shard Map Manager. Then we create the shards. Now, I already ran this because it will take 2 or 3 minutes for it to run. So you have to believe me, this code works. I ran before the session. What we have here is that we create a shard map. The Shard Map Manager can create several maps. It can control several shard sets, if you'd like, or shard maps, how they're called here. And then we create the tenants. We run across the number of tenants we want to create. In our case, it's 4. Then we create a shard. What does it do for creating a shard? As you can see, it gets an ID and the existing map. It's create an empty shard. If I go into this code, all it does, as you can see, is it creates the database. There's a SQL script here for initializing a database, an empty database, a shard. Here's what it looks like. It has a region table and a products table and a customers tables, and this is what we want to initialize a new tenant with. So it creates the database. Let's go back. And here we go here. And then it creates something called point mapping on the shard map. What do we tell it? We tell it that this is the ID that you want to associate with the database, and this is the database we just created. So we created a mapping. We told it tenant 1, this is the database. Tenant 2, this is the database, and so forth. And this is stored behind the scenes. It's stored in a SQL database, a separate database for controlling this. And it's all done for you behind the scenes. You don't need to touch it. In the application config, there's a connection string there to where it should connect, where it should store this data. But how do we use it in runtime? So this is called, right now, this code creates 4 tenants in advanced. Where is that? Here. Just that in advance when it starts, if it don't exist. Obviously, in a real application, you would call this every time you create a new tenant. Now, once you have these tenants up and running, and as you saw earlier, we have 4 databases in the Elastic pool. They are called tenants 0, 1, 2, 3, and 4, as they're defined in the code. Let's hope it will load soon. Okay, here they are. Here are those databases. You can see the peak for everyone, the average, their size. Right now, there's not a lot of data in there. But if I run this code, after I create the Shard Map Manager, I create the shards if they don't already exist, there's a small method. It's called execute data dependent routing query. Now, this method, what it does, it mimics the behavior at runtime, where you have a request. You know the tenant ID for that request. How do you know? That's out of scope right now, but usually it's in a property of a signed token or something like that, some claim you give to the user. And what it does, this is not, it entered the get connection string. That's not what I wanted. Here we go. So in our case, I just randomly generate a customer ID. Let's say 3, that's the tenant ID I want to update. Usually, again, this will come from the request, from the context of the request. And once I have it, let's say I want to add a customer to that tenant. So if I go in here, and this is the interesting code, And there's a retry policy here. It doesn't really matter. But what I want you to look at is this line of code. See here, shard map, open connection for key, free, and the connection string for the controller database. So what happened here is I don't really care about the separate databases and the connection strings and their names and everything. I have a mapping. I went to the shard map. I want to open a connection to the database of tenant ID X. Once I have that connection string, I'm connected to that specific database. Okay, and I can run queries, and I know that I won't get the wrong data from the wrong tenant because I'm bound by the scope of the database. Okay, so this is quite a powerful tool. Imagine you don't need to manage the shard yourselves. You can have a runtime which manages it for you, and then it does the query and goes to the correct tenant. But not only that, you might say that when we run this, let's say we have 100 databases, 1,000 databases, how do we manage it? Let's say we need to update our schema. Do you imagine going database one by one and updating the schema and everyone coordinating it? No, that's a lot of work. So luckily for us, another thing that we got from Azure with Elastic Pools is something that's called Elastic Jobs. And now I have a small script. Oops. All right. Now I have a small script here. What this does, it gets a credential for connecting to the pool. And then I want to run this script. For example, this script creates a table. I want to update the schema. And I want to run it across all of my tenants. So I create something that's called a job. I create a job content with the script. And then I specify the target. In this case, the target is the shard map itself. I'm using the shard map. But I can specify any custom set of databases that I like, or the old database in the pool. I can play around with it. I create the target. And then I create the job, and I tell it to run. And once I run this, let's run this code. It asks for my credentials, and let me enter my super secret password here. And it should run, hopefully, relatively fast. And this should go ahead and start the job. Now, when I want to print out the execution status, let's see where it stands, you can see that it's still in progress. We have one job, the parent job, which we created, and that job went ahead and scheduled 4 other jobs for the 4 databases. And it will go and coordinate, to retry, it will do all the operations required for updating the schema, and when I run it again, it should be completed by now. So here we go, it succeeded. We successfully updated the schema across all the databases in the pool. And you can do both schema updates, you can do queries across multiple databases in the pool, you can do all types of things with Elastic Jobs. So far, so good? Great. Let's get back to the session. So we saw an example of how we can get both resource separation, but still get the benefits of the cost for the scale. Now, one thing you can do is let the customer decide. Have you heard the word premium tier, or ultimate, or enterprise, or whatever? You can go with a shared architecture, a shared resource architecture, where you share resources for cost, and you know that you risk privacy sometimes, but you do your best to test it, and you know it's okay for your customers. Sometimes it's okay. Best effort, they won't ask. But sometimes there will come that customer and say, hey, I don't want my data stored with all of them. I don't care about them. I want to make sure that my data sits alone. It's not with anyone else. And I'm willing to pay for it. So a lot of times you can solve it as a premium tier. Let the customer decide. If the customer pays for the dedicated resources, they can have their own instance of the application. As far as you care, you just need to manage it into the cost. Okay, so this is not a technical question. This is a question for the marketing, for the product team, but you can definitely raise it and offer it. Maybe not for starters, but later on as the product progresses. Now, what happens if we need operations which are cross-tenant? Okay, we need to run some sort of query. Let's say we're running, and again, this is another customer that I have. What they have a multi-tenant system. And as part of the system, they're running a machine learning algorithm, which outputs all kinds of events for the tenants. But what they need is they need to get statistical information about the algorithm, about its performance across all tenants, so they can tweak it, so they can make it work better, so they can develop things more sophisticated. You get it across all tenants. Now, the best thing I can tell in this case is, first of all, be careful. You don't want to cross from one tenant to another just like that. But something else you can do, that's something I usually do, the tip I give, you should try and separate and isolate the problem as much as you can. Meaning, for this example, if we have, let's say, a database per tenant with all the information we need to gather, we can set up some sort of ETL process which extracts data from all the databases automatically into another separated database with only the data we need, only the statistics. Maybe it's anonymized, it has only the information we require, and then govern the access to that database separately. That will probably be used only by internal employees and stuff like that. So you should really isolate it as much as you can. Another example I gave you is with the customer at the beginning, with the subtenants to build the hierarchy. Again, that was another case that we need to have cross-tenant operations. So in that case, we had let's call it a super tenant, which had its own database in that case. And the subtenants, they were sharing a database. So it was a hierarchy. So we need to be careful inside the tenant, but we could at least get the reports we wanted across what we called subtenants eventually. So this is the question of shared versus dedicated. Let's talk a little bit about onboarding and provisioning. When you build such a system, you need to remember that as opposed to an on-premise system, you need a way to onboard new customers. New customers come in and they want this. They want a way to log into the portal, put the credit cards, pay you the money you want, and use your system. And that's another functionality which you need to think of. You need to think about the web portal. You need to think about the business logic behind the scenes, which provisions new resources, because if we have a database per tenant, we need to create the database. If we have some sort of tenant configuration, we need to update it. That's an entire process. Onboarding and also tenants who are leaving. You need to think about if someone is done or someone is updating their usage plan. You need to think about all these things. A lot of customers, you'll be surprised they don't think about it when they're onto the cloud. Ask them, well, how are the customers going to start using your software? And say, we didn't think about that. It's a good question. You really need to think about it. So here we have some example code. For example, this is using the Azure ARM SDK, for example, to create a storage account if you have a storage account per tenant. So we're creating a storage management client, .storage account called create a sync. And then we go and provision the required resources. This is behind the scenes. Now, obviously, you need a way to charge your customers. Again, billing, this is not specific for multi-tenant systems. It's generic software as a service problem, but it's still something you need to keep in your mind. So if we have this monolith architecture from before, now we have a new provisioning portal and a new section of business logic for tenant provisioning. The same thing goes to microservices. We need another provisioning portal, which is another UI. It's a separate client, and we need another service to handle all of this business logic for us. Another thing which we should consider is global reach. Where are our tenants located? And this is a requirements question. Are our tenants located in a specific region, America, Europe, whatever? Or are they global? If we have a company which all of it is located in Europe, for example, then great. When they sign up, they can tell us they want to be in Europe, and then we can provision the resources in Europe. But if we have a company with offices in both Europe and North America, we can't really ask them in which data set do they want to be. We need to be global. Again, this goes back to the shared resources question and the versioning question. Now, one thing to keep in mind is data residency. I don't know if your systems fall under it, but there are a lot of countries, namely a lot of them in the EU, specifically Germany and France and the UK. They have all kinds of rules that if you gather sensitive user information, you need to store it in that country. When you operate such a multi-tenant system and you have customers, especially if they're global, but part of their users are, let's say, in Germany, they need to store the data in Germany. You need to think about it when you build your provisioning process. Where do you provision the database, the storage account? Does a cloud vendor give you a solution for your requirements? And this is a product question. Do you need to think about it or not? This is a product question, but it should be in your mind. Let me skip encryption for a while. Let's talk a little bit about infrastructure. as I said before, if you have dedicated resources, you need to know where to route the request. I told you, if you're going to do Redis cache, you have an infrastructure which makes sure to add the tenant ID. And if you have multiple message services, you need to know where to route that request. These are all infrastructures. And these infrastructures, the common thing between them is that they handle cases in concurrently of multiple tenants. And these places need to be well secured, so you won't get up in this situation or the story I told you before with the customer getting the wrong bill. So my recommendation here in this case is have some sort of tenant management service. Have this one place, this one location. It could be a service, it can be a component if it's a monolith, it doesn't really matter. But it's one place where you can go, give it your token, for example, it will return you the tenant ID and all the configuration. That will be one place which will store connection strings, IDs of encryption keys, storage account identifiers, various secrets related to specific tenants. So we'll have one place and one place alone where this functionality exists, where you need to test this functionality, okay, and the point to test it, and which you need to secure. Okay, this obviously be a very basic component in your system. So if we go back to the architecture, instead of having the tenant provisioning, now we have some sort of tenant management logic with maybe a database or a data store. It doesn't really matter which type. The same thing in the microservices. We don't want just to provision it. Provision is part of managing a tenant. We want to have a tenant management service with its data. Okay. Let's talk a little bit about DevOps. And DevOps is a lot of things to many people. And I have a couple of things I would like to say about DevOps which are specific to multitenancy. So one word of advice, and it's a very important word of advice, and it's not specific to multi-tenant system, but it's emphasized in multi-tenant system, is this: automate. I always tell customers, or tell people, if you do something twice manually in the portal, then you're doing it wrong. Okay, it's very good to do something one time to try it out in the portal. It's very easy to experiment, to try out a couple of things, to test things. But then you should really consider automating it, because when you have manual processes, especially in this kind of system where you have multiple resources, multiple instances of each resource, then if you get an error, and I've had cases where customers had errors in the deployment process because it wasn't all manual, but it wasn't fully automated, then rolling back is much harder because you need to find out where was the error, which tenants were affected, and how they roll it back. So this is very important. The other thing which I'd like to say, and I'll close with this and this demo, is monitoring. Obviously, every system needs to be monitored. All right, it's no secret. I'm sure all of you do it. But in a multi-tenant system, it's very important that you not only monitor the entire system, you know, the response time, the failure rate, the exceptions, and so on. It's very important that you monitor each and every tenant, because you don't want a case where, let's say, some tenant has a problem, in this case, the one in the middle turned red. You want to be able to identify it for yourselves. You don't want to wait for the customer, for the tenant to call you and say, well, we have a problem. And if you only have like this big dashboard, you know, it's averaged inside all the data, and then you say, no, I don't see anything. It should work. I know what's the problem. But that specific tenant might be, his database might be on a specific server, or his web app might be experiencing some sort of failure, and you really would like to identify it at the tenant level before the tenant calls you. That would be much better. So how can we do that? Again, it really depends on what your technology stack, on what you're using. But I'd like to offer one option. Have any of you heard of Application Insights in Azure? Okay, you're already nodding your hands. Okay, that's great. Application Insights is a very powerful tool for monitoring your application. It can collect information regarding response time, failure rates, exception, it can collect your logs, it can do a whole lot of things. But what a lot of people don't know is that they can add their own custom data, or what they call custom dimensions, on top of each telemetry which is being sent to Application Insight. And you can do it from the infrastructure point of view. And let's take a look at an example. Again, all the code is open source on GitHub. You can look at it later. So what we have here if I open up this monitoring demo, I have a very simple ASP.NET Core web app. You see, it's just upload. It just starts Kestrel, and in the startup, we wire up a couple of things, which I'll go through in a second. And our controller, what it does, it goes to the HTTP context of the current request. It gets the tenant ID. This is an extension method, which I'll show you in a second. We just place it on the HTTP context. In this example, we take the tenant ID from one of the HTTP headers, which is totally unsecure. Usually, we'll take it from some sort of signed token or a claiming signed token. But for example, this is good enough. And what this code does, it checks if this is a bad tenant ID, in our case, 3 or 5, because that's what I decided. We punish it. What is punishment? We delay it. We randomly choose a number between 1 and 1,000, and we delay the request. This could be a database delay. This could be a lot of things that could happen. In our case, it's pretty trivial, but in real world, this could really happen if, let's say, tenants 3 and 5 on a specific server had a specific issue would cause them problems. Now, we have a client application here, which I ran it before the session started. It just starts up a loop and it just keeps sending more and more requests with a random tenant ID and getting back the answers. Now, but what do we do on the server? We have here some sort of middleware, which I call the tenant ID middleware. It's like I told you, it looks at the authorization header from the HTTP. And if it's a tenant authorization, it gets the tenant ID. I told you this is unsecure, but this is not the point. The more important thing is that we have this little guy, tenant ID telemetry initializer. And it implements iTelemetry initializer, which is something that comes out of the Application Insights SDK. Now, what we have here one method. Okay, it's called initialize, which we need to implement. It gets the telemetry, and the telemetry is every piece of information which Application Insights the SDK sends to the server, to the Application Insights server. And what we do with that, we get the tenant ID for that specific request, if it exists. And if we have a tenant ID, we attach it to the telemetry item. We have context, which is, it has a property bag. Then we have a property named tenant ID, and we place this number inside. So when I run this code, and I run the client, which creates a lot of requests, a lot of information will be sent to Application Insights. So I can run it now. This will build it. Here we have the console client, and I'll run it. It doesn't show a lot, but if I open my task manager, you'll see that it's using almost all my CPU. So it's doing something. It's working. It's calling the server, and the server is handling the request, and telemetry is being sent to Application Insights, which I created before the session. And the data I'm going to show right now is data which from right before the session, because it takes 2 or 3 minutes for data to appear in Application Insights, and I didn't want to wait for it. So if I open up Application Insights, let's close it. Here it is, the one I created. Then we can see, okay, this is from previous runs I had before today. So you can see that the average response time is 23 milliseconds. That looks great. 23 milliseconds response time for web servers, that's perfect. But if that's all I look at, then customers 3 and 5 will call me and tell me I have a problem. Something is not working right. But if I drill down in here, we can see that the operation, indeed the median is 0.14 milliseconds, which is great. But the 95th percentile is 183 milliseconds. Now that could be okay, that could not be okay. That really depends on your application. But if I drill down, I can add charts at every level. So I drill down into that specific operation, and I can add a chart. I can configure multiple types of charts. And let's say if I add a grid, oops, where it is now. If I add a grid, for example, I can group by, notice, tenant ID. Because this is the dimension we sent. It's a custom dimension. Now, if you do it from the start, it will take, again, 2 or 3, 4 minutes until this appears in the dropdown, so don't be worried if it doesn't appear right away. But if I add this chart, then we can see here that indeed, for all the tenants, we get very good performance. These two are anomalies. So if I have this on a dashboard, let's say across all operations for each tenant or the worst tenants, then I can detect if there is some sort of anomaly or not. Another nice things I can do with Application Insights, it has this nice little feature. It's called Application Insights Analytics, where it's like a dashboard where you can, for BI, for analyzing your analytic information. It has a query language. It's called Application Insights Query Language, AIQL. It's very similar to SQL, it reminds it, but you can see it also has IntelliSense in here. So I say requests where timestamp equals 30 minutes ago or something like that, and I can continue. But I have the query here already made. So let me type it here. So if I run this section right here, so I told it, give me all the requests from the last 60 minutes, take the tenant, define something called tenant ID from the custom dimensions, which I sent, summarize the average of the duration by tenant ID, and order by tenant ID. So here we go. You can see need 3 and 5. Let me increase the size of it a bit, if it will. Doesn't want to zoom in for some reason. I don't know why. Oh, here we go. So indeed, you can see indeed that 3 and 5 got worse results, but we can also chart it. So if I run the entire query, we can create a nice chart. We can see that 3 and 5 are indeed higher. This is undefined. This from a previous one I had. And you can take this, you can put it in a dashboard, you can put it in Power BI, you can build alerts on top of it, you can do many, many things and get, what I want you to remember is to get the analytics at the tenant level. Okay, don't forget that, it's very important. You don't want the customer to call you, you want the call to customer first. Let's get back. Okay, so what do I want you to remember from this session? Okay, you really need to define the tenant boundaries. It can be an organization, it could be a division organization. It's not a simple question. Sometimes it will be simple, sometimes it won't. It's not a technical question. Okay, ask the product or define it yourself if you're in the position to do that. Invest in your architecture. Okay, when you go to the cloud and when you have a system running 24/7, if you've done something wrong, it's greatly exaggerated. It's true for every system. But from my experience, when you go to the cloud, when you have a multi-tenant system, these things tend to show up pretty fast. Consider which resources are shared or dedicated, or maybe both, according to what we talked about. Don't forget all the things related to onboarding, provisioning, billing. You want to get paid in the end. Have a rock-solid infrastructure. Okay, test it. If you have, like I recommended, one place where this is isolated, like maybe a tenant management service, test it well, and you'll know you're in a much better position than you were before. Doesn't mean you don't need to check other things, but you're in a much better position. Monitor each and every tenant, like I just showed you, and the most important thing, earn a lot of cash. So thank you, everyone. My work is done. Go and ruin some systems for your enjoyment, and that's about it. So thank you very much.